Welcome everyone to Knox Game Design for July 2025. My name is Levi Smith. So this month we're going to be talking about a pellet eating maze game, how to implement this. I'm going to try not to say the name of the game that starts with a P, but I think we all know what it is. I'm going to do a quick design overview and also an implementation of this game. So first of all, here's a design that I came up with, a class design. So first of all, we're going to have a player and enemies, but both of those are going to inherit from an actor class right here. So under actor, we got a position, size, the direction that actor is moving, speed, how fast it's moving, a move method, collision method, and a can move to a position method. So in that we subclassed a player has lives, and player also has input, and enemy has whether it is alive or not. We also have two other main objects in the game. We got the walls, so the player and the enemy cannot move through the walls, and the walls is what composes the maze. Each wall has a position and a size. Basically, it's just blocks. And then we have pellets. So the objective of the game is to consume all of the pellets on the game board. So each pellet has a position and a size. So here's a quick state diagram that I did. So we're going to start out over here with the black dot over here. So we're going to start out by creating the levels. We're going to create the maze walls. We're going to create the player. And then we're going to create the list of enemies. So every frame we're going to update. We're going to check the input from the player, move the enemies, check the collision between the player and the pellets, check the collision between the player and enemies, then check the player between the player and the walls. So for each of these, you can see if the player collides with the enemy, we're going to decrement the number of lives and restart the level. If you follow it all the way over here, we got to reset level down here where we reset the player and reset the enemies. If the player collides with the wall, the player is just going to stop moving. We're going to have a Boolean value to track whether the player is moving or not. And then the collision between the player and the pellet. So if the player collides with the pellet, we're going to destroy the pellet. And then we're going to check it and see if any other pellets remain on the game board. And then if there aren't any more pellets remaining, then we're going to go to level complete, then reset the level and go to the next level. If the player did collide with the enemy and the player has no more lives, then we're going to go to the game over state down here, and that's kind of like the end state for the game. So here's an implementation of a pellet eating maze game. I'm going to do this in Visual Studio 2022. So we create a new project. It's going to be a MonoGame cross-platform desktop application. If anybody has any problems like setting this up, I did a presentation on MonoGame a while back. Yeah, so we're just going to go into Visual Studio and create a new MonoGame project. Just going to call this Pellet Eating Demo and set the location, call it Pellet Eating Demo. So the first step, so we're going to set the screen size to 1280 by 720. Standard stuff here. You get a really small screen if you don't. Small window by default. We're going to create an actor and a player class. So you just go add new item class actor CS and add new item class player CS. You can do that over here and make sure you change the name right there to actor and player. We're going to load and display a player sprite. We're going to load those into the MGBC editor over here. You just double click it in the Explorer within Visual Studio, and we're going to load them into this player.png. I just have like this little blue guy right here with two little eyes. You can make whatever. If you're doing this along with me, you can make whatever sprite you want to. I think I did a 64 by 64, maybe 32 by, I think it's 32 by 32. So yeah, in your MGCB editor, you just add an existing item, load in that player.png. You're going to load that with content load, texture 2D. And I always make a texture dictionary, so I have all the textures available, all the sprites available in one, just like one object. So I don't have a bunch of little textures defined everywhere. So yeah, let's take a look at this. So here's the code right here. It's pretty simple. Yeah, here's like the little explorer over here. So we got our actor class right here. So that's where we define the actor, kind of like in the design with an X and Y. Yeah, I went back and these really should be ints right here if you want to make your life a little bit easier. Like in a most of the time you hear is like in games, you want to have floats, but in this case, it makes it a lot easier if you just use ints. A width and a height, a direction that the player is moving, or enemy. That's one advantage of using object-oriented. This will be inherited by both the player and the enemies. So you got a direction, you got a speed, you got a move method, and a collision method. And we're just going to return false right now. We don't care about collision right now. So the important thing over here, we got our player, not much defined yet. So we got a player, and the player extends the actor. If we look in our main game class, you can see here, let's see here, in load content, this is where we got our texture dictionary right here. And then we're adding, just call it player, whatever we called it in the MGCB editor, and we're going to load that in. And we got our update method, not doing much right now. We got our draw method. We're just going to, the first step is just to see if you can draw the sprite to the screen to get started. We're going to have a rectangle. We're going to put it in the middle of the screen. That's what the screen width divided by 2 and screen height divided by 2. We're just going to use the default color, which is white. By the way, so I have screen width and screen height defined up here as public static ints. And just FYI, you can use this in your constructor. You can use graphics preferred back buffer width and set the screen width, and preferred back buffer height, the screen height. That's what sets the size of your window. So I'm just going to run this, and you should get a gray window with one little character here in the middle. And oh, by the way, looking at our draw method, we do have graphics device clear, color light gray. That's what makes it a gray window. So that's step 1. Or step 0. Step 1, get the player moving. Get the player moving by default, and whenever you press an input, such as a keyboard input, we're going to change the direction. We got our check input method right here. We're going to create methods on the player object to handle each input, up, down, left, and right, and set to the direction value. Then player.move, we're going to, so I ended up not using delta time because it makes things a lot trickier when you're doing collision. But yeah, on player move, we're going to set the new X and Y position. Right now, yeah, I'm just using the int speed variable in the end. I didn't do the times delta time in the end. Just keep things simple. Player will move that many pixels per, and actually it's per frame. We're going to, I think, start out moving 2 pixels per frame. So player.draw, we're going to implement a draw method on the player. So in the main game method, it's going to call the player.draw. We're going to pass in the sprite batch object so we can draw the sprite. And then the tricky part is rotating the sprite on the current direction. So you got a couple of options here. You can create one sprite that gets rotated, or you can create separate sprites for moving up, down, left, and right. But in this case, I wanted to use one sprite for all 4 directions. But when you start rotating sprites, you got to make sure you're rotating at the center of the sprite. So let's go back over here. So as always, I'll post all of the code in a online code repository. Anybody wants to look at the code or anything. So we got our game. Let's look at our player. We got our player. So we added some code in here to initialize the player's position. Like I said, right now it's using the floats, but I ended up changing it throughout the demo just to use ints. Yeah, so we're going to increase X and Y by the speed. Then we implemented input up, input down, input left, input right. So we're just going to set the direction whenever pressing any of those buttons. Here's our draw method. So this is where we're doing the rotation. We're getting the rotation of the sprite. We're going to start out by default default sprite is looking to the right, 0 rotation. If it's down, we're going to rotate. And this is all by radians, so you're going to do 0.5 pi. Left is 1 times pi, which is pi. I just add the 1 just for consistency. And then up is 1.5 times pi. And default just set to 0. And here's our draw method. We're going to press in the XY location, width and height, the source rectangle of the sprite 003232 white by the rotation. Then we got to offset it back to the center. Yeah, you got to make sure you do 16 by 16 right there, or else weird things will happen. And then no sprite effects and 0. So and then if we look at the main game class, let's go back up here. Here's our update. Update is going to call check input, then player move. Check input, that's just checking if is key down up, is key down down, is key down left, is key down right, and then it's going to call player input up, player input down, player input left, player input right. Then, like I said earlier, the draw method is just going to call player draw. So let's look at this. Yeah, for some reason there I was missing the textures, add player content load right there. So I got that added back in. So now if we press play, we're going to see our character is going to start going up by default. And I'm pressing the buttons. You can see them right there. Move them left, right, up and down. There's no bounds checking, no collision. But this is how I make a game. You just got to get something moving to start out with. And unlike a lot of games, you just press the key once to change direction. You don't have to hold down or anything, because we're doing a pellet eating maze game. Not to mention the name of the game that starts with a P. Okay, so that's step 1, get the player moving. Step 2, add the pellets. Create a new pellet sprite, add that to the MGBC editor. Create a list collection of pellet objects, draw pellet objects to the screen. And I will mention, if you're doing a game in Unity or I don't know, whatever your favorite, Godot or SDL or Allegro, it's all kind of the same stuff. Actually, this would be pretty easy to convert to Unity, just because it also uses C# scripting. If you're doing SDL, then you're going to be doing C, or Allegro, you're probably going to be doing C, or C# or C++. So here's step 2 of the pellet eating demo. So you can see we added the pellet class right there. If we open the pellet class, here it is. They're 8 by 8. It's got an X position and a Y position for the pellet. And then we're going to draw the pellet right here. We're going to offset it by 8, 8. And then if we look at our game class, so this is where we're actually creating the list of pellets. Pellets gets a new list of pellets. Make sure you import the system collections generic, or else you won't get list. So you're just going to loop through the screen size, and at each 32 pixels, we're going to create a new pellet and set the pellet's X and Y position. Then we're going to add that new pellet to that list. And here's where we're loading the pellet sprite right here. And then we're going to draw. We're just going to loop through all the pellets with a for each. Then draw, pass in the sprite batch and the textures. So let's run this. So here it is. Not doing anything, but woo, there he is right there. Kind of slow in the magnifier. But yeah, it's just an array of pellets. I'm just using these red diamonds for pellets. I think it's 8 by 8. Yeah, 8 by 8. Okay, so that's the next step. Continuing on, step 3 is adding the collision. Add collision check method to the actor class on each update. Check if the players collide with any of the pellets. If true, then remove the collided pellet from the pellets list. So yeah, you can do that one or two ways. You could check to see if the player collides with the pellets, or check if the pellets collide with the player. It seems like it's just simpler check if the player has collided with the pellets, but you can do it either way. So let's go to pellet eating demo 3. So if we look at our player right here, yeah, here's our check pellet collision right here. We're going to pass in the list of pellets. Yeah, we're going to leap through all the pellets. So the reason why I'm doing this, I gets pellet count -1, while I is greater than 0, I minus. It's kind of a weird way to loop through an array, starting at the end and going through the front, but it's because we're going to check the collision, and if it collides, then we're going to remove it at that index. If we start at the bottom and go up and start removing stuff, then it's going to really mess up with the index. It's going to mess up the indexes, and then you get lots of errors because you're removing stuff at the beginning and everything else is getting moved down, and then you're going to get out of bounds, exceptions, and all that. So that's why we're starting at the end and going to the front. If we look at the actor, we have our collision method here. Right now it's using floats, but I think I do change that to ints later. Makes things simpler. So yeah, if anyone's out there is curious about the collision code, I did a talk for Knox Game Design a while back on 2D collision between two rectangles and all sorts of 2D collision. But basically you check to see if one rectangle is to the left, one's to the left. If it's not, if it's either above or it's to the left or below or to the right, then it hasn't collided. But if you OR all those and then not that, then it has collided. So if none of those conditions are true, then it has collided. So you got to kind of think backwards with that. So yeah, that's all this is doing right here. This is kind of standard stuff with 2D box collision right there. It's really simple code. If x plus w is less than the other x, if x is greater than the other x plus the other width, or if y plus the height is less than the other y, or y is greater than the other y plus the other's height, then it has not collided. Otherwise, it has collided right there. So yeah, I think that's all that's going on right there. So we look at our update. I just added the player check pellet collision pellets right there to our update. Let's look at it. I don't know if I showed the code for like removing, but you can see as he moves along right here, if I can track this guy, you can see the pellets are being quote unquote eaten, destroyed as he goes through this maze right here. So yeah, you can kind of see he's eating 2 at a time. Sometimes that gets fixed later. That's one of the reasons I use ints, to keep everything rounded and nice. So if we look at player, yeah, I think I've mentioned it. We're just removing from that array. So we don't actually destroy the pellet. We just remove it from the pellet list. So in our game, when we're drawing, we're only drawing the pellets in the pellet list. So it's actually still out there. I don't think anything's pointing at it. So I'm thinking it'll probably get garbage collected. There's nothing that's pointing at it. Okay, step 4. What do we do? And I will go ahead and mention that you can do these in any order. You can add the walls before you add the pellets. You could even add the enemies before you add the walls, or whatever you really want to do. I think the first step is really getting your character moving around, but you could implement enemies first, or implement the walls first. So this, just because I say this is step 4, you can do these in any order. So step 4, add the walls. Create a new wall sprite, add that to your MGBC editor, create a list of wall objects, kind of like with the pellets, instantiate the wall objects, detect collision between the player and the wall, stop moving, the player collides with the wall. I mentioned earlier, we want to have a boolean to track if the player is moving. Actually, I also have that direction variable within the actor, And I think later on I added a direction none. So we usually just start out with up, down, left, right. I think I also have a direction none later on. Um, so it, that prevents the player from moving. Be sure to move the player out of the wall. So if you do collide into the wall, I think I do the collision detect before, but if you're doing the collision detect after you've moved into the wall, make sure you move the player back outside the wall. Usually you want to like just do the player x plus width equals the wall width if you're going the x direction, or player y plus the height gets the y position. So you just want to make it even with the wall if you go into the wall. So if you start moving again, enable that moving boolean. Only allow change the direction if there's no wall collision. Otherwise, if you press like down and you collide with the wall below, then the player will stop moving. So if the player's moving forward, you only want to stop the player if they move directly into a wall and they stop. But if you just press down and you go into a wall, you just want to keep the player moving the way they were before. It's kind of like an invalid input. It's kind of like the player is just holding down. So yeah, I'm passing that game object. It's kind of like a game manager. I just didn't create a separate game manager class. I'm using that game one as kind of like the game manager. So I pass that as a parameter to the player, the wall, and pellet objects. That way the player can access the wall and the player can access the pellets without doing passing a lot of that around as parameters, which gets kind of messy and gets to be a headache. And this is where I found out that it's a lot better to use int values for position and speed. You can use floats and cast them, but with a game like this, when you're detecting going down like these little corridors, it's easier just to use round numbers. Yeah, the collision gets messy when you use floats for a game like this, so it's easier to just do ints. So step 4, let's look at the code. Over here, let's go Pellet eating demo 4. So you can see over here we had the wall class wall, pretty much the same as our pellets, except it's 32 by 32. Then we're going to have a draw method. We're not rotating. I could just take that rotation out right there. Really, that's why it's underlined in green, because I'm not using it. Then in our main game class, so this is where we're creating the walls. I just set it up in the constructor, got an INJ integer for tracking, so with 32. So we're going to draw a wall all around the top, wall on the bottom, walls on the left and right. And then I got kind of some code right here that says, hey, yeah, we're only going to draw a wall for every other row. I is 0. Yeah, so if I mod 2 equals 0, yeah, this is the one that kind of carves out the maze. So you could actually change this right here with like Prim's algorithm or something if you want to make a really more interesting mazes than what I have in this demo. But yeah, this I mod 2 equals 0. That just says we're not going to create a wall for every other row. Then we're just going to put kind of like column aisles down through here. Jmod 10 does not equal 1, and J8 does not equal 38, just to carve out at the very right side. So if those aren't equal, then we're going to create the wall object, add it to the wall list. There's our pellets. So yeah, nothing. So we do have a player check wall collision method that I added. So if we look at player, so check wall collision. So we're going to loop through all the walls. This could probably be optimized right here because we're checking every single wall, and really you should only like check the walls around the player. But we are a collision method right here. If we looked at actor, yeah, that's the same collision method. I did add a check wall collision where we pass in the wall objects, and then it's going to check the differential Like if you pass in the player, or this is the player by default, but I want to know if the player is going to collide with the wall in the next frame. That's what this X diff and Y diff are doing right there. So I can check to see on the next frame if they're going to be in the wall or not. So that's all that's doing right there. Yeah, so if you do collide with the wall. So right now I'm just like moving the player in the opposite direction, I think. I think that's what I did. Let's just play and see what happens. Pellet eating demo. So there's our player. So just moving along. And then when he hits a wall, he's going to stop, but I can press up. He's going to move up. And then I'm press over. And I think I did have a problem like earlier. That's why I tried to change it to ints, is like the player would kind of like get stuck. But I'm moving the character like 2 pixels per update right here. So yeah, he's eating the pellets. He's not colliding into walls. So everything's looking pretty good so far. Okay. Okay, next step. Step 5. So now we're going to add different game states. So the real reason why I call this game states, I kind of lumped in game states with level complete. So whenever you consume all of the pellets, then we're going to go to the complete state. So we got a game running state, then we got a game complete state. But I just went ahead and add the title screen and the ready state as well. So title screen is just going to start when the game starts up. Ready state is like right before the level starts, just a brief delay. So we got title, running, ready, and complete. And later I'll have a game over. So I just have a state enum, added state enum to the game class, title ready, running complete. If there are no remaining pellets in the pellet list, then set the state to complete. You just need to check that whenever you consume destroy a pellet. I don't think you need to check that every frame. I may do that, I can't remember. Title state displays the game title, ready state. So it's going to reset the stage. I actually am doing a little bit during this ready state. It's resetting the stage, updating the layout, resetting the player position, instantiating pellets, and instantiating the enemies. Because after you complete a stage, you want to load the next stage and create all new walls. And you don't have to create a new player, just reset the player's position. And even with the enemies, if you just set them to is alive as false, you don't have to recreate them, just reset their positions. So running state, that's where our gameplay is. Complete, level complete, that's just going to say level complete to the player, just to give the player a short break. So let's go back to the code. Step 5. So I just put it, I think I just put it in the game class, I think. Up here. So we got our public enum state right here, title ready, running complete. Also added the sprite font in the MGCB content editor over here. So we got our font large font just so I can display text to the screen. So I got a ready countdown just to track the delay. So yeah, you can see here now, I probably could do this with a switch statement, but I just have it in an if, else if. So I got on our update, if state equals title, then we're going to delay for 3 seconds till the user presses space. Then we're going to reset the level. State's ready, then we're going to have that ready countdown, then switch over to the running state. If state's running, then that's our old update right here. But I added if pellet counts equals 0. So I am checking if pellet counts equals 0 on every update right here, which really should only have to check it whenever a pellet is removed. We're going to set the state to state complete, and the state's complete. Then we'll wait for the player to press space, and then reset the level and reset the ready countdown. I actually have this in separate methods later on. state transition. So that's really all we're doing right there. Let's go ahead and run this. So there's our title screen. Press space. Ready. Here, I kind of sped up the player to, I think, 8 pixels a second. I found out it works as long as you're staying within powers of 2. Like I said earlier, if you're using floats, it makes the collision really messy when you're dealing with fractions of a pixel and trying to figure out if the player is aligned with one of these rows or not. So that's why we're doing ints. But yeah, just eating up all these little pellets here. Get the one by the cursor right there. You can see them fly by. And there we go, level complete. So that's the next step in our pellet eating maze game, just to make sure that once you consume all the pellets, then you get the level complete, then reset everything, set up a new level. Now, if you're going to make this into a full game, you might create a new level layout, increase the difficulty, things like that. Maybe have an intermission screen before you go into the next ready state. Okay, so we're getting there. Step 6. This fun part, adding the enemies. We're going to add the enemy class, extending actor. We're going to add sprite, the draw method to draw the sprite. Oh, and here I just created one white colored sprite and then used the color property of the texture draw method to change the color. Implement the move method. Later on, I'll let the enemies change direction. I want to check and see if the enemy is collide with the wall. If they collide with the wall, move in a new direction. Check for collision with the player. Subtract 1 life from the player if it collides with the player. Reset the player position. Reset enemy positions. Transition back to the ready state if lives are greater than 0. Otherwise, we add a new game over state. Transition to game over state if lives equals 0. So let's look at step 6. Right here. So where's our enemy? Here's our enemy right here. Double click that guy. There's where we're keeping track of the enemy color. We're going to have 4 enemies, all different color. They're going to move at a speed of 2. So this is where I changed everything to ints. I can't remember if in MonoGame there's a fixed update or not. I'm just using the update here. So if there's like slowdown, it might get a little bit janky. But yeah, just using ints to make this simple right here. We've got our check wall collision right here. Basically right here, what all I'm doing is like, hey, if the enemy bumps into a wall, then they're going to go in the opposite direction. That'll be changed on the next step. So we're just going to draw the enemy. So the enemy really doesn't change its appearance based on the direction that it's moving. So I just use this simple draw. And then I pass in that color parameter right there to change the color of the enemy. If we go look at the game class, you can see, I add this transition to title state right there. And then we've got the enemy list of enemies. We're going to clear the enemies when we reset the level. And this is where we're creating the 4 enemies right here. We're going to set the X and Y position, reset the position on the game screen, set its color for either red, yellow, cyan, or magenta. We're going to use these number values here to set the position, initial position of the enemies. Then we're going to add those to the enemy list. This reset actor positions, that's just when the level's over with. We're going to reset the player position and enemy positions. This is where we're loading the enemy sprite right here. So yeah, I'll just go ahead and show. If you go into the MGCB editor, you can see and click on like, it doesn't show a preview. Enemy, double click. Yeah, there's our little enemy right there. So yeah, we're going to change the color with that color parameter. Here's where we're saying, hey, set up the player with 3 lives. I guess the other thing is when the game is running, we're going to check player with player enemy collision right here. Then for each enemy, we're going to move the enemy and check and see if the enemy has collided with the wall. So player, check enemy collision. We're going to loop through all the enemies. If they collide with an enemy, the lives is going to go down by 1. If lives is greater than 0, we're going to transition to the ready state, reset the level. Not completely reset the level. We're not going to recreate the pellets. We're just going to reset the player and enemy positions. Or if the lives is equal to or less than 0, then we're going to transition to the game over state. That's all there really is to it. Pellet eating maze game, ready. So we got our 4 enemies moving around. They're pretty simple. They're just going to move, and I think right now, they bounce. Yeah, right now I just have them bouncing off the wall, but just to show, if you collide with an enemy, it's going to transition back to the ready state. And then I have the number of lives displayed down there. And then if you get to 0 lives, then we're going to go to the game over state right here. Then wrap back around to the title screen. Yeah, I guess I should mention, like, down here in the draw method. So the draw method is kind of like our update. We're going to have a different if statement for each state. If we're in the running state, we're going to draw the number of lives right here. Show the player the number of lives that they have. Yeah, I think that's it for the player and enemy collision. I guess I didn't show the player movement. The player's just going to use move. Maybe I did show that. Pretty soon, if player's moving up, we're going to subtract speed from Y. Player's moving down, we're going to add speed to Y. If the enemy's moving left, then we're going to subtract speed from X. If the enemy's moving right, we're going to add speed to X. So this is kind of like if you're doing Game Maker, you just use frames, use ints. Makes things a lot simpler. Okay, so now we're going to make the enemies do stuff. So this is kind of like enemy AI, enemy behavior, whatever you want to call it. So I'm just going to do like a simple implementation. Want to check, I got this cam move direction. So on each update, we're going to check to see if that actor can move in which of the 4 directions. So what I did is I made a list of valid move directions. You can probably implement this different ways. So I'm just saying on each frame, can the player move up? Can they move left? Can they move right? Can they move down? And I add that to a list, which probably isn't very efficient, but just for this demo, that's the way I did it. And I used a random next to generate a random int from 0 to the size of this valid move collection. So the enemy at every intersection has an equal chance of moving forward or turning in any valid direction. What's nice is when I get that direction back so valid moves is a list of directions right here. So I add that to a valid moves list. What's nice is down here, if there are valid moves is greater than 0, then I'm just going to say direction of that actor gets valid moves random.next 0 to valid moves count. So it directly assigns that direction variable value into that actor's direction property. So it automatically starts moving in the direction. You don't have to do anything. There's a lot of enhancements you can make, like figuring out where the player is and trying to move the enemy toward the player or trying to trap the player, things like that. And even more complex, you can do pathfinding algorithms. If you have a really complicated maze, you can do like a star algorithm to try to figure out where the player is and try to have the enemy move toward the player. I know like Game Maker has a star built in, I think, where it can kind of do that for you. And then there's also a site here which, for further reading, I'm not going to say the name right here, but in another popular pellet eating maze game, go right here and get the behaviors of the enemies in that pellet eating maze game. So this one thing that I found really interesting is like there are actually algorithms for determining where the enemies, which way the enemies move in this game. Yeah, so that's basically it. Let's go to demo 7. So this is it right here. That's what I had on the slide. So basically, if the enemy's moving left, we're going to check continue moving left or move up or down. If the enemy's moving right, check if they can continue moving right, up or down. If they're moving up, check if they can continue moving up, left or right. If they're moving down, check if they can continue moving down, left or right. So I think essentially you can move the collision, like the other collision detection out of the enemy, because on every update it's going to check and see what valid directions it can move in. But I went in and left check wall collision in here just in case. And this is where I had the direction as none. So if they do collide into a wall and for some reason they can't move in any other direction, they're going to move in no direction. If we look at the game class right here on status running, for each enemy, we're going to check change direction. Is the enemy able to move in a new direction? If so, we're going to pick one of the valid directions that the enemy can move in. Then move the enemy, then check wall collision, which I think could probably be removed. So here it is, right here. So you can see now the enemies are a little bit more interesting. So for every little intersection, it's going to pick one of the valid directions. So it isn't just like, hey, they're moving. So it actually kind of looks like he's chasing me. But it's kind of interesting. It's like you think they're chasing you. You think the AI is chasing you, but it's really not. It's really just moving in a random direction, which I think's pretty wild. But yeah, if you don't have that check to pick a random direction, if you just pick one direction, the enemies will start moving in loops or circles. If you always say, hey, always move up or always move left or always move right, they'll end up kind of all clumped up in the same area. I had that happen when I was implementing this. I was like, okay, you got to add the valid directions to an array. And then, and yeah, so I did speed up the character just for the demo, just because I want to speed it up for debugging and testing sake. Usually when I'm making a game, I do things like that. And then once you're ready to release, you slow it back down for other players. And then maybe you could have it as you go to higher levels, increase the game speed, increase the player speed, increase the enemy speed. So yeah, what's next? You can add it power pellets. I didn't do that. In the other game, there's a scatter mode. So when you eat a power pellet, then you can eat the enemies. Do not have that in this game. This is just a simple demo. Add a score saying how many pellets the player is eating, or you can add bonus items that you can eat, fruit, whatever, jewels, things like that. Don't have any sound effects or music, but that would be something to add. Have a sound effect play as you eat the different pellets, and improve the graphics. Update the graphics in it, make it look flashy and snazzy and things like that. So anyway, that's all I have for the pellet eating maze game for Knox game design July 2025. Hopefully everybody out there found it helpful and interesting. I'll have the source code out there if anybody wants to take a look at it. So until next month, see everybody back in a month.